All right, good afternoon, majors. So we are starting Unit 7. This is actually Unit 7.1, not 2. The Pythagorean Theorem and its converse would be the first topic we're going to be talking about. So in order to save time, I decided to just use the already pre-filled notes to go through the notes and see if that helps. So today we're going to learn about Pythagorean Theorem and its converse. Okay, so yours is going to be in one page. Mine is going to be in each will be different page. Okay, but it's the same note. So what is Pythagorean theorem? And I'm sure you have heard of this word before in your 7th grade math, 8th grade, or algebra 1. But whenever you have a right triangle, the sum of this square of the measure of the two legs equals to the sum of the measure of the hypotenuse. The hypotenuse is always the one opposite to the C, opposite to the 90 degree, and is already labeled as C in this case, but always when you look at the 90 degree, across from it is going to be the hypotenuse. The other two legs are just called the leg of the right triangle. So whenever you have that, you can do a squared plus b squared equals to c squared, or the hypotenuse squared equals to the sum of the square of the two legs, which is a squared plus b squared. Okay, so now we can apply this in solving problem. So first thing I want you guys to do every time you see a problem is identify where the C is. The A and the B doesn't matter if you interchange them, but the C matters, okay? So when you cross multiply, when you go right across from the 90 degree, that kind of helps you to see where or which one is going to be the C. I can label this as A and I can label this as B, or vice versa. So A and B doesn't really matter, but C matters. So the hypotenuse is always going to be C. So in this case, C matters. I can label 25 as my A or X as my A. It doesn't matter. Okay, so how do we solve it? As you can see, it's A squared plus B squared equals to C squared. The C is the 15. A in this case is 9. B is X, so we did 9x plus X squared equals to 15 squared. 81 equals X squared equals to 225. Since I still did not solve for X, I minus 81 from both sides, which gave me X squared equals 144. X is the square root of 144, okay? So just remember, X is the square root of 144. So that, if you guys don't know how we jump from x squared equals 44 to 12, we took the square root of the number. Same thing goes for the number 2. A squared plus b squared equals to c squared. A squared is 25. B we don't know. C is 65 squared. Then you minus both sides from 625 minus 625. You get 300, 3,600, which is the square root of that is going to be 60. All right, sometimes you might see questions like this. So when you look at number 1 and number 2, they're both given a right triangle and they ask you to solve for the missing sides. But when you look at number 3 and 4, it doesn't look like a right triangle problem because they gave you a rectangle and a kite. So you might get confused. Okay, how do you solve for a problem like this? But it's the same thing. If you ignore the top part of the rectangle, it just gives you a right triangle, which you can still apply a squared b squared equals to c squared. In this case, the opposite to the 90 degree is your x, so that's going to be your c. So you're just going to simply do a squared, which is 16 squared plus 23 squared equals to c squared. In this case, the c is the 28. Okay, opposite from the 90 degree is 28. So C would be 28, A and B would be the other two sides. Okay, so if you plug in the numbers, solve for x. This is what you would get. I hope you guys know what you're doing, and it's simply simplifying. You can put it in a calculator or put it, if it can be simplified, you have to simplify it in simplified radical form. In next class, when I see you, we will learn about how to simplify radicals. I think we went over it before, but if you guys don't remember, we can go over that too. All right, so the next thing we're going over is a Pythagorean triple. It is a set of 3 positive integers. Integers are not fraction, are not decimal, but when you take those integers and you do a squared plus b squared c squared, it would satisfy that, okay? So in this case, we started, for example, 3, 4, 5. The multiple of 3, 4, 5 by 2, by 3, by 4 would also have a Pythagorean triple, meaning if you take 3 squared plus 4 squared is going to give you 5 squared, 6 squared plus 8 squared equal to 10 squared. So it always helps to memorize a couple of the Pythagorean triples instead of always trying them, multiplying them. But if you memorize a couple of them, then it saves you time as you go through it, okay? All right, the next thing we're going to do is the Pythagorean Theorem Converse. So this is very important, but one thing I need you guys to remember is even if we are saying this is what we're to determine if a triangle is right, acute, or obtuse, the first thing we need to do is we gotta determine, can we use the measurement to create a triangle? And we went over this in Unit 6. So one thing I want you to do first is to add up the two smallest side. Is it greater than the third side? If it is greater than the third side, then you're going to determine to see if it is a right triangle or if it is right triangle, right? Or if it's an obtuse triangle, or is it an acute triangle, okay? So how do we know, or how do I know which one is which, okay? So the rule is, if a squared plus b squared equals to c squared, like this, then it is a right triangle, okay? But if a squared b squared is less than c squared, meaning if c is more than the 2, it is an obtuse triangle, okay? And the last one is, if a squared plus b squared is greater than c squared, meaning c is less than the 2 sum, it would be an acute triangle. This is important, but you always need to remember, can this length become a measure of the right triangle? So what I did in the next set is I look at the numbers first. I said, is a plus b plus c equals to more than c? And in this case, yes, 18 plus 24 is it more than 30? Yes. 20 plus 30, is it more than 40? Yes. Okay, because it gives you 20 plus 30 gives you 50. 50 is more than 40, right? 4.5 plus 6, is it going to give you more than 7.5? Definitely. So now I can just go ahead and say, okay, then if it does, is it a right triangle? Is it an acute triangle? Is it an obtuse triangle? So I still do the same thing. The largest number is your c. So I did a squared plus b squared. Is it equal to c squared, more or less? So when you start plugging it in, you see that the first one is a right triangle. The second one is an obtuse triangle, because when you add the sum of the two smallest side, or the legs, is going to be less than, so if c is more, right? Just always look at c. If c is equal, it's right. C is more, it's obtuse, and C is less, it's going to be a right. Okay? All right, so in this case, number 9 is not a triangle, okay? Because 2 plus 10 is not more than 12. Because it's not a triangle, you just say not a triangle. You don't need to do anything with it. Okay? But the others, you have to kind of determine which angles are going to be, which sides are going to be acute, right, or obtuse. Okay? A squared b squared, is it more than c squared, equal to c squared, or less than c squared? Okay? All right. Next question is asking you to solve 11 and 12. 11 is asking you to solve to find the length of the missing side of the triangle and the area of the triangle. So to find the missing side, you do a squared plus b squared equals to c squared. Okay? And then you take the side that they gave you. But the only problem in this one is they give you the altitude, which is 10.8, but they did not give you this side. But you have the hypotenuse. So you will put x as one of the side you don't have, and then you solve for 5.23. 5.23 is half of the whole base. So you have to times it by 2 to find the measure of the base, because area of a triangle is 1/2 base times height. So 1/2 the base is 10.46, 5.23 times 2. That's how we got to this place. And then the altitude is 10.8. So you just multiply it and you find the answer of the triangle. All right, for the last question, I hope you guys know what a baseball field look like. It looks like a diamond, and how it's labeled. So each base of a standard softball diamond is 60 feet from the next, and the catcher is standing 3 feet behind. So kind of away. If this is the home plate, the catcher might be 3 feet behind. And then, you just have to solve for the length from the catcher to the second base. So you do a squared plus b squared equals to c squared. So you'll find x is 84.85, but you have to add 3 so that you know where it is exactly. Okay? That's what we have to do. All right, that's it for this section. I hope you guys will be able to do the problem. And make sure you finish page 1 to 4 of the classwork package after you watch this video, or we will do it in class. Okay.